Hello everyone, in today's video we are going to solve one more LeetCode question, that is question number 86, partition list. So in this question we are given a head of linked list and a value x, and we have to partition this linked list in such a way that all the nodes less than x comes before the nodes greater than or equivalent to x. And we have to preserve the original order as well. So let's see how we can solve this question using this example where this is the given linked list and we have to partition this linked list using this x, given x is equivalent to 3. So in our example our x is 3 and we have to partition this linked list on the basis of this value. So all the values which are lesser than 3 are going to be on the left side, and all the values which are greater than or equivalent to 3 are going to be on the right side. So what we can do is we can create separate two lists for left and right partition. So like I will create two dummy nodes, like first one will be for left and second one will be for right. So these are my two dummy nodes. And what I'm saying now, let's traverse through this whole linked list and we will update these two dummy nodes next pointers. So firstly I will come up to this node and its value is 1. So what I will check is 1 is less than 3, right? And as 1 is less than 3, so what I will do, I will simply point my left dummy node's next pointer towards this node with value 1, right? And then what I will do, I will go to next node, that is 4. Again I will check the same condition. Is 4 less than 3? No. So if this is not true, then what I will do, I will update my right dummy node's next pointer and I will point that pointer towards this node with value 4. Fine. Now again I will proceed and go to this pointer, that is go to this node which is 3, and I can see that 3 is not less than 3. 3 is not less than 3, so it will go to this node. It will go towards right portion, right? So I will again point my right part. I will add this node in my right partition. I am not adding this node, but I am pointing the next pointer of the previous node from right portion towards this node. So this is what we are doing. We are not creating any node. Now again what I will do, I will update my pointer and we will proceed towards next node, that is 2. Again I will check 2 is less than 3, so that's true. So what I will do, I will update my left partition. So now this node 1 next pointer is going to point toward 2. This is 2. Now again I will update my head and go to next node, that is 5, and again I will check the same thing. Is 5 less than 3? No. So if 5 is not less than 3, it will go to right side, and again I will point my node 3's next pointer towards 5. So this is how we reached up till this node. Now again I will update my pointer and point towards this node, last node. Again I will check the same thing. Is 2 less than 3? Yes, it is less than 3. So what I will do, I will update my left partition. So now this next pointer is going to point towards 2. And this is how I traverse the whole linked list. Now after traversing this whole linked list, what I saw is both the partitions are. Now what I have to return is, I have to return the partitioned linked list. So what I will do, I will simply take the last node of this left partition and points its next pointer towards right node's next pointer. I will take the next pointer from the left partition last node, that is 2, and I will point it towards the next pointer of right partition's head. So in this manner the end result will be 1, 2, 2, 4, 3, 5, and we can see that this is the answer that we were searching for, right? So in this manner we can create two partitions using two dummy nodes, that is we have only created two nodes, that is left node and right node, and then what we did, we simply updated the next pointers of all the nodes, and at the end we joined these two partitions, and then we will return the left partitions head, and this was the whole solution. So what is the time complexity of this whole solution? Let me just clean this side so we can discuss the time complexity and space complexity of this solution. Solution is pretty straightforward. The problem is pretty straightforward, and I really like this question. So what we did is we traversed this whole linked list only once. We hadn't traversed this whole linked list twice or thrice to create these partitions. So our time complexity is going to be big O of n, where n is the length of linked list. And for space complexity, we can say it is big O of 1. Why it is big O of 1? Because we are creating only two dummy nodes, that is left and right, and rest we are using these same nodes from the given linked list. We are simply updating the next pointer, right? So we only use two dummy nodes, and that is going to be constant because we are always going to create two partitions, and for that we only need two dummy nodes. So the space complexity will always be constant. So this was the whole explanation. Now let's jump to the coding part. So firstly, let's define our two dummy nodes, that is left comma right. So this is how we initialized our left and right dummy node. After that, what we are going to do, we are going to define the tails of these dummy node, which we will be updating. So this will be left and this will be right. And after this, what we have to do, we have to run a while loop, and we have to run this while loop to the point we hadn't reached the end of our given linked list. So what we are going to do, if head dot val is less than x, right? So in that case, we are going to update the left tail. So left tail dot next is going to be equivalent to head, and then left tail will be left tail dot next. So this is the first condition, and if this condition is not true, what we are saying, simply do the same thing for right. Right tail dot next is going to be equivalent to head, and right tail is going to be updated with it next. Right tail dot next, and at the end, what we are doing, we are updating the head pointer, that is head equivalent to head dot next. And after stepping out of this loop, what we have to do, we have to join the two partitions, right? So what we have to do is, firstly we have to end our linked list. So right tail dot next will be equivalent to none. This has to be out of loop. After this, left tail dot next is going to be equivalent to right dot next, and we will be returning what I just wrote, God knows, returning left. We have to return left dot next. Okay, so this is working. Now let's submit this and we'll see if it's working for all the test cases or not. So yes, it's working, and we can see this whole solution is quite optimized, and I hope this whole solution and this whole video was helpful for you all. And if you find this video helpful, then you can like this video, subscribe my channel, and I will soon come up with more such videos. Till then, keep watching, keep coding, and thanks for watching.